Is it graphs?
Should be an easy day. No graphs. Yeah, we're just doing math.
Can I use my calculator to do all my math? Hey.
Alright, so today we are reviewing something that you've seen before, synthetic division. We are going to be using this later on in the chapter as we start looking at different polynomials and rational functions and their graphs. But today we're just basically talking about our division. The division algorithm says if you have two polynomials, f and g, as long as g is lower degree, then there exists unique q of x and r of x, such that f is equal to g times q plus r. Sounds really confusing. All it's saying is you can divide two functions and get a quotient and remainder. That's the unique q of x is the quotient, r of x is your remainder. If I asked you to divide this, so if I had to do long division, okay, we are going to divide these polynomials. Okay, think about, you don't have to write this down, but think about your little thought bubble over here. If I told you to do 273 divided by 4, okay, you would set that up. Then what would you do? Has it been so long you can't do long division by hand before? Can you do 4 divided by, or 2 divided by 4? Can you do 27 divided by 4? Yes, and it goes 6 times. And then you do 6 times 4, which is 24, and we subtract that off. You remember this process? We are going to do the same idea over here. Alright, we are starting out. We're just going to divide our leading pieces. So if I ask you to do 6x squared divided by 2x, what would that give us? 3x. Technically, it doesn't matter where you put it. I like to just write it above my x term, but you're not wrong if you put it somewhere else. Now, once we got our 6, what did we do? We did 6 times 4. So I need to do 3x times my 2x plus 3. So I know how much to subtract off. So 3 times 2x, 3 times 3. Oh, I dropped my x, didn't I? That's a 3x. So 6x squared plus 9x. Alright, so we divided, we multiplied. Now what do I need to do? Subtract. If I want to subtract this, the easiest way is just to run a negative through and then combine like terms. So 6x squared minus 6x squared, those cancel. 5x minus 9x. And then we just bring down this negative 10. Okay, I didn't have anything to subtract from it, so it just comes down. Alright, same thing. When we are working over here with numbers, we subtract, 3 comes down, and then you're back to the beginning. So now you have to do 33 divided by 4. So that's what we're doing now. I'm going to do negative 4x divided by 2x. What's that give me? And then you multiply. Negative 2 times the 2x plus 3. What's that give us? And then I need to subtract that off, so what would I do with my signs? Change those signs. Positive and negative 4x cancel. Negative 10 plus 6 is negative 4. Okay, can I do negative 4 divided by 2x? No, so that's our remainder. Typically, how we'll see that written, 3x minus 2, that's my quotient. You can write plus negative 4 over 2x plus 3 if you want, or just minus 4 over that. But you put your remainder, that negative 4, over the thing we were dividing by. So that is long division.
Let's go back to graphs. No.
Obviously something a little bit new. You haven't done a lot of dividing polynomials. We're taking it step by step. Have I lost you guys? I'm not gone. Let's go through another one together, step by step. It's really a 3-step process. You divide, you multiply, you subtract. Repeat. So that's what we're going to do here. So the thing I'm dividing by goes on the outside. You notice I went from an x squared to a 1. You don't have to, but if you want things to line up, I like to put a 0x in there. That way I don't get confused when I'm trying to combine like terms later. So if you're missing a power of x, it's not that you'll get it wrong if you don't have it, but it might be a little bit easier if you put in a 0 placeholder. And the thing we're dividing goes on the inside. So, it's 3 steps. Step 1, we divide. What do we divide? Yep, just those leading terms. So what is 5x cubed over x squared? Now you can put it anywhere. I just like to line up my terms. So this is a 5x. I put it above my x term. What's my second step? We have to multiply, so we have to do 5x times my x squared plus 0x plus 1. So 5x times x squared, 5x cubed, 5x times 0x, 0x squared, that's why I put the 0 there, so I have it under my x squared term. 5x times 1 is 5x. What's step 3? Subtract. Easiest way to subtract, just run a negative through. And then combine like terms. So 5x cubed minus 5x cubed, those are gone. Negative 4x squared minus 0x squared is just negative 4x squared. 7x minus 5x is 2x. And you just bring that minus 2 down. We didn't have anything to subtract. Alright, I'm back to step 1. What's step 1? Divide. You divide those first terms. What is negative 4x squared divided by x squared? Step 2, multiply. So you have to do negative 4 times the x squared plus 0x plus 1. 4x squared minus 0x minus 4. Step 3, subtract. So if I run a negative through, combine like terms, negative 4x squared and positive 4x squared cancel, so I get 2x plus 2. Can you do 2x squared, or sorry, 2x divided by x squared? No. And that'll always be the case. Once you have a constant up here, you're not going to be able to go any further. So that's my remainder. So my answer is 5x minus 4, that's my quotient, plus my remainder, 2x plus 2, over what we were dividing by, x squared plus 1. Better? Okay. One more together. Do you guys all see how we write the final answer? So, the thing I'm dividing by goes outside. 2x squared plus x minus 1. The thing I'm dividing goes underneath. X cubed is 5 halves x squared plus x plus 3. What's my first step? Divide. I need x cubed divided by 2x squared. It gives me x over 2, or you could even write it as 1/2 x. You want it? So it's okay to have a fraction. What's step 2? So I take 1/2 x times my 2x squared plus x minus 1. So that gives me x cubed plus 1/2 x squared minus 1/2 x. Then what do? Subtract. So change all of our signs. Positive and negative x cubed cancel. 5 halves minus 1/2. 4 over 2, which is just 2x squared. 1x plus 1/2 x, so 3 halves x. And my plus 3 comes down. Alright, we're back to the beginning. Divide, the first ones. What is 2x squared divided by 2x squared? 1. Anything divided by itself is 1. So then we multiply 1 times the 2x squared plus x plus or minus 1. And then what do? Subtract it all off. So if we change our signs, positive and negative 2x squared cancel. 3 halves minus 1 be a 1/2 x. 3 plus 1 is 4. Can I go any further? No, I already have my constant up here in my quotient. So this is just my remainder. So I have 1/2 x plus 1 plus 1/2 x plus 4 over the 2x squared plus x minus 1. That's kind of ugly because I have a fraction and a fraction. Can we fix that? If I wanted to get rid of this 1/2, I would have to multiply by it 2. If you do it on the top, you have to do it on the bottom to get an equivalent fraction. And we're just doing that in the fraction. So then I would have x plus 8 over 4x squared plus 2x minus 2. And again, the only reason I did that is because I had a fraction and a fraction, and it just looked ugly. I was cleaning that up. And it's always legal to multiply both the numerator and denominator by the same thing. Any questions on this? Okay, so long division has its place, and we will have to know it at some certain points. But there are some problems that can be done in an easier way, and that's the case if you are dividing by something linear, something that x to the first is your highest power. In that case, we can do what's called synthetic division. So if I want to find the quotient when we divide by x minus 4, could I do this with long division? Yes, absolutely. Synthetic division is basically taking out all the variables and just dealing with the numbers. You have to look at what you're dividing by. X minus 4. What makes that equal 0? 4. So I'm going to put a 4 out here. And then I'm going to put my coefficients. I have a 3x squared, so I'm just putting a 3. Sorry, 3x cubed. And negative 2x squared, so I'm putting negative 2. Do I have an x? No, so what should I put in its place? And then my constant was negative 150. doing this before. So in synthetic, the first number comes all the way down. So the 3 comes down. Now it's just a series of multiply and add. The reason on long division we subtract, here we're adding because we already did the opposite when we did the positive 4 here instead of negative. So I do 3 times 4, 12, and then I add. Negative 2 plus 12 is 10. Multiply. 4 times 10, 40. Add 0 plus 40, 40. 4 times 40, negative 150 plus 160 is 10. So this only works if we're dividing by something linear. At this point, this number is your remainder. This is your constant. And then just increasing powers of x. So that would be x and then x squared. So my answer is 3x squared plus 10x plus 40. Plus, my remainder was 10 over what we were dividing by, which was x minus 4. So synthetic is kind of a shortcut for us in certain cases. If I look at this one, show x plus 3 is a factor of this expression. What does it mean to be a factor? It's divisible by that. So what should be your remainder when you divide them? 0. Okay. So if I'm dividing by x plus 3, what number goes in my box? What are my coefficients? We didn't have any missing powers that we had to put in. 0 is 4. The 2 comes straight down, and then we just multiply and add. So 2 times negative 3 is negative 6. 5 plus negative 6 is negative 1. Negative 1 times negative 3 is 3. Negative 2 plus 3 is 1. 1 times negative 3 is negative 3. Plus 2 is negative 1. Negative 3 times negative 1 is 3. Plus negative 2 is 1. 1 times negative 3 is negative 3. Let me get a 0. Did I even ask you what the quotient was here? No, I just said show it's a factor. The remainder is 0, so it's a factor. That's the definition. Factor divides evenly. So if I'm asking you to prove that it's a factor, you're just dividing and showing me that you get 0. If I did want to write my quotient, we would just say, okay, that's my constant. X squared, x cubed, x to the 4th. Or we could think it was x to the 5th. When you divide by x, your powers are going to go down by 1. So my quotient is 2x to the 4th minus x cubed plus x squared minus x plus 1. There is no remainder. So, few things to remember. Synthetic division only works with linear factors. You have to use zeros for any missing powers of x, and the last number you get is always your remainder. This is a really cool result, the remainder theorem. It says if the polynomial f of x is divided by x minus k, the remainder is equal to f of k. Think back here. If I'm trying to show it's a factor, the only thing I care about is my remainder. The remainder theorem says, okay, if I took this negative 3 and I plug that in for x, grab a calculator and just type this in. if you plug in -3 for all of your x's, what do you get? Zero. Where did we see 0? The remainder. So if all I care about is the remainder, I could do synthetic division or I could just plug that number in. So that is a very helpful trick. Alright. The other thing, I just have a definition here. If I ask you to find the zeros, that's the solutions. Or another thing of saying like places where the graph is equal to 0, x-intercepts. If it's a 0, your remainder is 0. So if I want to know if 2 would be a 0, you could choose to do the whole synthetic division with a 2. The only number I care about is the final one. Or you could use the remainder theorem, which says all you really have to do is plug in a 2. What do you get? So what you guys got? Okay. Yeah. So, what does that tell me? Not a 0. It gave me my remainder. My remainder is -14 if we divide, so it doesn't go even. So if I want to know if -3 is a 0, plug it in. What do you get? 0. So that means this one is a 0. Last problem of the day. I want to know if 1 plus 3i would be a 0 of this. Can I just use 1 plus 3i on my calculator? No. So if I can't just easily plug it in, what else could we do? We could do our synthetic division. Okay? If I give you this value, that's what goes out in the box. And then I put my coefficients. I'm going to leave myself a little extra space between these. Let's see why in a second.
Does it not change to negative?
It doesn't because it doesn't have the x with it, so I already did the opposite of it. Okay. So first, 1 comes down. Then we multiply. What's 1 times 1 plus 3i? -1 plus 1 plus 3i. We just combine like terms, so the -1 and 1 cancel, and we get 3i. So now I have to do 3i times 1 plus 3i. So if I distribute, I get 3i plus 9i squared, which is, do you guys see where I got that? Like terms, positive 6 and -9 is a -3, and we still have this 3i. Alright, this one just got ugly. So I have 1 plus 3i times -3 plus 3i. But we've done imaginary numbers. We know how to multiply this. We just might have to come out to the side and work it out. Bless you. So I get -3 plus 3i minus 9i plus 9i squared. Okay, 9i squared is negative 9. 3i minus 9i is negative 6i. So I get negative 12 minus 6i. 20. How many do you have?
It's 2 off.
You're close.
No.
Thank you.
Yeah, no problem.
Alright, is everybody with me? So if I combine my terms, I get 2 minus 6i. So I have to multiply one more time. 1 plus 3i times 2 minus 6i. So by FOIL, I get 2 minus 6i plus 6i minus 18i squared. What happened to my 6i's? So I get 2 minus negative 18i squared would turn into positive 18, which is 20, and I get 0. So, is this one a 0? So, I could give you imaginary numbers here. It doesn't involve any math we haven't done before. We've added, we've multiplied with imaginary numbers. It just takes a minute to go out to the side and work them out. Are there any questions? So I have a handout for you. You're welcome to do it on here, or if you write big,